So here we have a model which demonstrates the bending moment of a beam when you apply a certain force on it. In this section we got 4 pins connections on each side. So when you apply force on the top where it's pinned, as you can see, these sections do not move. But when you apply force on that side and you tilt it, you can see the structure is not stable, either this way or that way. Okay, so in this section we have 3 pin supports and 1 fixed right at this support. When you do apply a force on top of here, you can see that these don't bend. When you apply a force this way, there's a moment at this section here, while there's no moment here and here. When you apply it the other way, again, this section bends. There's a moment here, there's no moment here, and there's no moment here.
Okay, as you can see here, we got pinned, fixed, fixed. When you apply the load at the top here, nothing happens to the beams on the side. When you apply the force from the side here, you have a buckling load of roughly 0.7 on both sides due to pinned and fixed. Same thing with the other side.
Alright, so in this section here, we got 4 fixed supports. In the previous example, we had 2 fixed on the bottom and the pins are on top. And you can see that in the pin support on top, these sections here did not move. They had no bending moment on there. And when you apply the force on top with this structure here, with the supports, you see that there's a bend here and here as well, due to the applied force on the top. But when you apply force this way, you can see that each beam there has an effect, and you see the bending of each beam. So you have right here, at this section, and at this section. Same thing applies to the other side. A slight curvature here, here, and there. In this section here, we added an extra floor, as you can see, and what happens is we have 4 pin connections, and when you apply a force on top, again you see this section here, there is no bending in it. When you apply a force in this direction, the structure will fall, and also as well as this direction, the structure falls. Game.
We'll just cut this piece out. No?
Oh yeah, I did, yeah.
Looks good.
Now that we have added a beam right in the middle, and we still have 4 pin connections, when you apply a load from the top, again, these 2 beams here do not bend, as well on the bottom, so does not affect the support on the bottom. When you apply a force in this direction, you can see that here there's a slight bending. You see here takes the maximum amount of bending here, as opposed to this section, this section, this section, or that section. When you apply a load in the middle, you can see these 4 beams are bending, meaning that the force being applied is affecting all 4 of these beams. In the previous example, when we had the pin connection here, 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 and here, we found that the structure was not stable and it fell to its sides. Now that we have added a fixed position here and here, but the top is still pinned, when we do apply a force in this direction, as you can see, the structure is stable from the bottom and it's fixed from the bottom. The only thing that's affecting is this portion of the structure. As well as also when you put a pressure from this side, same idea. The structure is still standing, but again, you would need a connection here to make the structure stable 100%, so it won't fall on its own. As you can see, it's still a little bit wobbly here. So as soon as you add the connection here, the structure will stand on its feet.
Okay, here we have a fixed, pinned, fixed, fixed, pinned, pinned connection. When you apply the load at the top, nothing happens to the sides. No moments are being applied because it's due to pin and pinned. When you apply the force from the side over here, since it's pinned and fixed over here, there's the buckling load of 0.7. There is moment in this section because it's pinned at the top and fixed here, and there's also fixed connection here. Okay, when you apply the load from the middle here, when you apply the force from this angle, this is fixed and fixed. The length is estimated to only be half of the length, and for here it's 0.7 due to fixed and pinned. When you apply the load in the middle here, downwards, you see that the top is being pushed in on each other and the bottom is pushed away, meaning there's moments being applied. Okay, so this is how we made it between fixed and pinned. Right now the structure is fixed on this end and it's able to rotate freely using a hinge that we found in the door department. To make it fixed, we added this L bracket. We just slide it behind it so that it's flush, and we place a bolt through it. And we bolt it together. To make the structure fixed.